Hey folks, welcome back to our Data and API show for a new episode on automated API deployments with our GitHub integration feature that we just released a couple of weeks ago. Awesome. So um, let's get started with what we're going to look at today. The agenda looks like we're going to try out GitHub deployment. We're going to connect our repository on GitHub with a Hasura project, and we'll actually end up deploying schema changes and metadata changes through Git push. Um, and so there are multiple use cases for this. So assuming you have like a cloud project, you typically start developing on, let's say, Hasura Cloud. You created some tables. Now you have some migrations and metadata that you need to port to your local setup, right? So that's one use case. The other use case is you actually started with your OSS image on your local dev, and then you want to now move to staging or production on Hasura Cloud, and you want to continue developing locally and keep pushing changes to your staging or production environment. Right. So just quickly looking at some comments. Hey, Brian. Awesome. So these are a couple of use cases. The third use case could be moving between Hasura Cloud to Hasura Cloud. You have like a staging instance on Hasura Cloud, and you have a prod instance on Hasura Cloud, right? So these are three use cases where Git deployment would make it easy for you to develop quick and rapidly apply migration metadata automatically, taken care of the background by Hasura. Awesome. So our first use case is that we're going to create a Hasura Cloud project for this demo. So I'm going to just create this project and I'm going to create some tables. And assuming that this is my initial workflow where I experimented with some quick boilerplate tables and schema, and I want to now move to a local dev setup and then continue developing and then do a Git push based deployment. Right. This is the first use case, so we'll look at that first. Awesome. So we've got the console ready. I hope the screen is visible. Yes. Just gonna zoom in. Yeah. I'm gonna go to the data tab and create a quick Heroku database. The usual steps that we do for our project creation with database setup. So once the database is set up, we already have some kind of metadata which is generated because this is a connection string that gets generated, and you already have like an env set up in the background, right? So there's already some metadata which is getting generated with this step. So the next step is to now modify the Postgres schema itself. So I'm going to create some tables, typical author article schema that I generally like to use in demos for simplicity. And I'll choose create a timestamp and primary key. So this is author. And let's click on create table. Got it. So now we have these three columns and whatnot, and we've got the APIs ready. All right. So now let's assume that this is our initial experiment. So uh, we've gone through the workflow of experimenting something with cloud, and we have this table and we have some metadata. The database connection is your metadata, and the table author being tracked is also another metadata. Right. Now you want to port this over to your local dev setup, right? So the typical process would be that you create a Hasura CLI project on your local machine and then do a Hasura migrate, create, and whatnot. The other approach is to do a PG dump of your Postgres schema and use that initial SQL file as your migration for the Hasura migrate create step. So there are a couple of inputs that are possible. Either you actually use the Hasura GraphQL endpoint as your migration creation step, or use a pgdump SQL for your migration creation step. We're going to use the first step, the Hasura CLI way of creating a migration file. So let's get started by actually initting a Hasura CLI project. Let's call this cloud to local, because we're moving from Hasura Cloud to local devs is the nomenclature. Let's move to cloud to local. So we have the initial CLI project directory structure, metadata, migrations, feeds, config. Uh, the files would be empty right now because we've not exported or created anything on any of these files. So the next step would be to create some migrations from your external server, which is the Hasura Cloud project. So let's do that by saying Hasura migrate create. Let's look at the options that are available. So we have SQL from server flag, right? This would take pgdump from the server and save it as a migration. So this is something that we'll probably use for this. We can also point it to a SQL from file. In this case, if you are taking a pgdump directly from the database, you can make use of that as your input file for this migration step. So I'm going to make use of Hasura migrate create init. And I'm going to say from SQL from server. So this would be SQL from server. And we need to pass the endpoint and admin secret. Right. So we have a couple of things to point. So the endpoint would be the project URL comes from here. So I'm going to paste this, and the admin secret, we can copy it from this. So we have this command that's going to create a migration file from the Hasura project on cloud, and it's going to initialize a migration file, an app.sql file for you to get started with. So the next input that we need to give is what database name are we going to use for this step, right? So I'm going to make use of default, which is what is being used on cloud as well for the first database that we set up. This is creating the migration file. So migration files have been created. Just to confirm the database name default. So this is the database name default that comes up on the screen. So this is initially given default when you use Heroku to create a new DB. But if you are creating a database, if you're connecting to your own database, you can give your own name, or you can even rename this default to something else as well, right? So that's the default name that we have used as an input in this step. Now let's relook at the migrations directory. Now you can see that there is a default source that's been created, and there is like an init migration file that's been created. We can even look at what the content of that file looks like. This would be up.sql, and I just file contents, and this looks like create table public author and auto sequence and whatnot. The typical SQL commands that are required to create this table. Awesome. So we have the author migration created. The next step would be metadata export, because we have the metadata from the previous step, right? So again, if I use this step, I need the admin secret and the Hasura project URL, right? So I'm going to make use of this. I'll say Hasura metadata export. I'm going to remove this flag. I'll use the endpoint and I'll use the admin secret for this. So this is going to give me the metadata that's already on the Hasura Cloud server. If I do a tree over here, you can see that the metadata now has been populated. So you have the tables public author .yaml coming up over here. Right, so we have both migrations and metadata uh, generated from whatever was there on Hasura Cloud. The next step to note here is we already have the table author created on Hasura Cloud, right? So the next time we do something like Hasura migrate apply, we don't want this migration file to be reapplied again because the table already exists on the cloud project. So we want to mark it as something that we want to skip this file the next time I do some migration apply, so that we don't have a conflict that ends up not applying anything because it's a transaction, right? And if the first migration fails, you don't get to apply any of them. So here the problem is we need to basically make this migration as applied. So the server needs to understand that this is a migration that it's already been applied on the server, and it can basically skip the execution of this particular file and then proceed with the other migrations, right? So this is all done through the versioning of migration files. So here, if you look at this particular one, this is the version number, which is starts with 1629. It's basically a timestamp value. So the more migrations you start creating, it's all sorted by timestamp, and that's what is getting applied on the server. So we want to now mark this particular one as something that we've already applied, right? So I'm going to just do some help to see the flags that are available to do this. So we have something called skip execution, which just says skip executing the migration action, but mark them as applied. So this indicates the server that this is already applied, but then actually don't go ahead and actually execute the SQL statement. This is something that we're going to use for this particular uh, uh, command. And the other thing that we want to do is we only want to apply this for this particular version. So only apply this particular migration for this particular command. So we need a couple of things. I'm going to make use of this again. So I'm going to say migrate apply. So we have the endpoint and admin secret. So the next step would be we need to now pass in skip execution and also the version number. Let's do skip execution. Let's also pass in the version number. So the version number would come in from this particular portion. So the migration directory will have the version number of for each migration file. This is a directory name. We'll skip the underscore init bits of this. So we'll just copy the actual timestamp value of that version. Right, so this is the command. So we're seeing Hasura migrate apply, skip execution, give the version that I want to skip the execution for, and give the endpoint and admin secret as we typically do. Right, so I'm going to do this, and this is going to get applied to Hasura Cloud. Again, I have to give the database name. I could also give it as part of a flag the next time. I think the database name is the flag that you can use to skip this input step. Right, so now the migrations have been applied. Basically, we have told Hasura Cloud project to now not take this particular version to apply. So we're done with that. We have created metadata and migrations and synced it to your local directory. The next step is to run your local Docker compose setup. So let's just check Docker PS, nothing's running. So I have this Docker compose.yaml, which has the Postgres version 13 and the GraphQL Engine 2.0.6, the open source version, with the metadata database URL configured to my local DB. So I'm going to run this saying docker compose up-d. The latest version of Docker lets you run compose as a separate subcommand rather than docker-compose. Cool. So now this is Docker PS, everything's running. So we have our local version of GraphQL engine running. Go back to cloud to local. If you look at the config.yaml, we have localhost 8080 as endpoint and version 3, which is the latest of the metadata version, the CLI config version, sorry. Now the next step is for us to apply the migrations and metadata to the local DB, to the local Postgres instance. So if I, in fact, open this tab and go to localhost 8080, this would probably not have anything, right? So we'll be empty. We don't even have a database connected. So for this to work, what we need to do is we need to now connect to the database. So what I'm going to do is, in fact, just a quick check on what the database connection URL in we was. We will go to metadata databases. Again, databases.yaml. So we look at this configuration on the Hasura Cloud project. We used Heroku database, right? Which is coming from this env called Heroku underscore database underscore URL. So if we are applying this metadata and the migrations from this particular sample, we need to ensure that the same database, same env is being used on the local project as well. Which means I need to now go to Docker Compose and create the same URL for Postgres. So it should be Heroku database URL, which would be the same Postgres URL. So I'm going to make use of same Postgres DB for metadata and the database itself. This might sound weird using a Heroku database URL on your local machine, but you can actually technically rename the database env that's being used, right? So if you go back to the default over here, go to data. So you see that the database is this. You can actually edit this connection string to point to a different env. With Heroku, if you're using a different env, then you need to ensure that the URL, that the connection string, which changes every few days, you need to keep updating that to keep it in sync, right? So if you're using this particular env, which is managed by Hasura automatically for you, the sync happens in the background and you don't need to worry about that. So that's, so for simplicity, I'm going to make use of the same env over here, but in a production environment, you obviously will have your own set of envs and which will be auto configured by yourself. Right. This is going to be the first change that I'll make. So I'm going to again restart this. I should have probably started with that configuration to begin with. So now I've added Heroku database URL. So let's go to cloud local and the next. So since the config has the endpoint configured to localhost 8080, I don't need to actually modify anything. I'm going to do Hasura metadata apply. This will actually apply whatever that's there on my local directory that which is exported from cloud to the local project. The next step would be Hasura migrate apply, and to the default database migrations are applied. We also need to do metadata reload. So this step is important because when we initially applied the metadata, it would be inconsistent due to the table not being there on Postgres, or maybe even some EMV not configured correctly and whatnot, right? So this would get fixed once we actually do the migrate apply step, because the migrate apply will actually create the table in Postgres. So the metadata will initially say that table author exists, even though the Postgres table doesn't actually exist. So once you do the migrate apply step, the table will actually be created on Postgres and the metadata will get in sync. But for that sync to happen, you need to do something called reload, so which will reload the metadata from scratch, and then it will basically sync the Postgres tables that have been created with metadata already applied. Got it. So now I'm going to make use of Hasura console, which is going to open on my browser tab. So I'm going to make use of, so to do that, change to 9695. So this is already applied now. So we see that the default schema has been applied. Going back to data, we can see the database connection. The environment variable is coming from here, and the table author has been created with the same set of fields. So the metadata and migrations have been applied, reloaded correctly, and everything's working. Awesome. So now the next step would be to connect to a GitHub repo, so that now we've changed this to a local setup. Now we want to make changes to this particular local setup. We want to create tables, make changes to your schema, establish more relationships, permissions, and whatnot. And you want to now apply that to your cloud instance, right? So for that to happen, we need to now set up Git deployment. So this is the project page, right? So we'll go to something called Git deployment on the sidebar. We can do a sign in with GitHub to start configuring the project. So we'll click on sign in with GitHub. I've already configured my account on this. So I'm just going to close. Yes, I'm going to close this one. And yeah, this is authenticated now. Right, so I need to select a repo now. So I'm going to create a new repo for this on GitHub. So let's say data API show demo, and let this be public repo, and you can create this repository. So I'm going to copy this. Now what we can do is go back, git clone this repo. Right. So in fact, what we can do is I can just add this as a remote. So git remote, add origin, and then add this git init, sorry, and then do this remote addition. So let's verify that we've added the origin remote. Now it's already on master. I can initialize this by adding these migrations. I can just say init migrations and metadata. Do a git push master, and we create our initial commit to get started. And here we have, so we've directly pushed it to this repo. So what I'm going to do is create a new branch, or let's say new feature that I'm going to work on. And here I'm going to make use of the Hasura console again to make use of schema changes. So let's go back to this, refresh this localhost 9695. So we have this author table. Let's just zoom in a little bit. I'm going to create this new table called article, integer, we have title, and we have author ID, which should be of type integer. Let's use timestamps. And ID is the primary key for this. And we can also add a foreign key, which will point to the author ID. So I'm going to say author ID points to ID. So I've added a foreign key now, and finally I'm going to click on add table. So now we've created a new table, but this is on localhost 9695, pointing to localhost 8080 server, which is on my machine, right? And I'm going to click on track all for adding relationships. So we've done a bunch of changes. We have created a new table. We have created a relationship between these two tables. We can verify that on the API Explorer over here. I'm going to open this in a new tab and just quickly do a tree. We can see that a new migration directory has been created for this public article table. Up and down SQL has been generated, and we also see metadata changes for the article table that was just created right now. Awesome. So I'm going to do a git status so we can see that there are some changes. Now, what we want to do here is go back to our Hasura Cloud, set up this deployment to select this repo. So the repo is data and API show. And we want to push this to, say, on this new feature branch. I'm going to say add a table. The new feature branch, right? I'll probably need to do a refresh. Go back to settings, Git deployment, and Git API show. I can new feature. Yes, I have pushed it. Let me verify this. Yes, we have two branches. Let me try this again. Data API show, and we have a new feature branch coming over here. The directory would be whichever directory we actually want the Hasura, the config.yaml file wherever it resides, the Hasura directory, right? In this particular repo, it's actually the root of the repo, which means I don't need to specify a specific path. But let's say this was inside another directory. All of these metadata migrations were inside a Hasura directory. We would ideally give something like this, which is Hasura slash whatever, some directory structure that we typically have. In this particular case, it's on the root. So I'm going to just leave this as empty, and I'm going to click on deploy. So if you look at here, so we've configured this mode to be automatic, which means that every time there's a git push that happens, a deployment happens automatically, right? To get started, I'll actually do a manual deployment because this is the first time we're deploying. There's a commit that's been pushed right now, which is 2 minutes ago that we pushed for the article table. Now I want to do this. So I want to apply this change first, and I'll just do a deploy now trigger. We can quickly look at the logs as well for this. So there'll be like 4 steps that will happen, which will like parse the metadata and then apply it, then apply migrations, followed by doing a health check to see if everything is perfect and reloading the metadata. So you can see the metadata has been applied. We can also see the diff between what was applied and what has changed from the previous step, right? Even migrations, we can see which one was skipped and which one was applied. If you remember, we skipped the first migration by saying skip execution. The first time we did the apply, that's going to be skipped, and the next one was applied right now, and the metadata has been reloaded. So this is the logs for this particular setup. And now I'm going to go back to API to see that there is an article query that's being generated, which means the table article is generated. So let me go back. The console state is not aware of the table. So I'm going to click on article, which has these columns that we created from the local DB. Awesome. So now we've seen a manual trigger for deploy. So the next step would be to again continue this feature. So I'm going to go back to 9695, my local setup, where I'm going to create, let's say, a permission. Let's say user say select with the checks and toggle all and save. So this will be like a metadata change that happens. Let's go back to this and we can see that there is a metadata change over here. So I'm going to do a git commit, add permission, and I'm going to push this to the new feature branch. So Brian has a question. Requested some time back and don't have this option for GitHub integration. That's weird because we've actually enabled GitHub integration for those who requested on the beta access earlier, and I think even now, I think it's probably even public for everybody to try it. So do log in and check it out. Maybe if your project is on an older version, which is probably on 1.3, then probably that might not work, but 2.0 and above should definitely work. Right. So I actually totally missed showing the automatic applying of this particular add permission step. So so the moment we did a git push, this deployment log started showing the add permission step, which prepared this log setup. Basically, uh, the permission that we added locally that was now being automatically applied onto the cloud project because a git push happened. So the push was listened by Hasura Cloud and then was automatically taken care in the background to get applied. So we can verify this by going to the article table permissions, and you can see the select permission has been added for without any checks and for all columns. So this is the magic behind Git deployment. So you keep working on your feature branch, configure it to your cloud project to say that this is the branch that I want to deploy whenever there's a change. There's a directory that I want to listen to for the migration changes. And you keep pushing changes, keep pushing commits to your branch, and Hasura will take care of deploying them automatically for you. Right, so that's the workflow for moving from like a cloud project to a local dev. So the next use case would be where I have this local project already, new feature, and this metadata and migrations and whatnot. I want to now move this to a Hasura Cloud project. So let's create a new project again with free tire cluster. So what we're going to do here is on the local machine, I already have some migrations and metadata. I want to now move this to like a staging environment on Hasura Cloud. So this would again involve slightly similar steps in the sense of configuring Git deployment and then doing a Git push. But fundamentally, since you already have the Hasura CLI project locally, you will avoid creating that again as we did in the previous example. So just waiting for this to provision. And the next step would be to configure Heroku DB again. If you remember, our local setup actually had the local DB database.yaml configuration had a Heroku database URL in. Right. And just waiting for this to provision, and meanwhile we can actually look at that metadata database.yaml, and this URL, this env will be used again in our new cloud project. So the only thing to ensure between your cloud and local dev setup is the usage of env variables in your metadata. They need to be the same across different environments, right? And especially with this particular use case of using a Heroku DB, it's important to use this particular env on your local machine. If not, if you want to take care of it on your own, you can obviously do it by changing the env that's being used. So let's go back to data and create a Heroku DB again. This is going to be quick. So once we do this, we'll again connect to our Git repo, which we created now. Awesome. So we have the database created and connected. Let's go back to Git deployment. And again, I'll sign in with GitHub. I've already configured it. So I'll remove this. And on the repo, I'll choose Data API show. So for this, I'll choose the new feature branch again. And directory, I'll probably leave it, or probably we can move this to a new branch called staging. This to staging. This might require another refresh. If I show, hopefully, yeah, this might require some more time to reflect the branch that we've created. So let's go to data API show. So I'll wait for some more time. Let's verify the change in the GitHub repo. So yeah, with 3 branches, you have staging that's being pushed recently. Let me actually refresh the page. Cool. Let's go to settings, Git deployment, and data API show demo. Staging branch ready. Directory will again be the same, and deployment mode will be automatic. Awesome. So we have add permission commit that's here. So I'm going to click on deploy now. So this is going to take a bit of time to parse it and then apply the migrations and metadata that's there. So the first step would be to apply metadata, which will have the database env that we used. And the next step will obviously be around migrations. This time around, the entire migration files that we created across multiple steps will be applied in one shot to the staging DB. This is because we've not squashed them. We have them as multiple files. Right. So this is the project, and we have the tables over here. Again, there's a console issue. Let's refresh this. And let's go to article and show some permissions. We have a select permission as well. So we have actually replicated the entire schema and my metadata over from our local project to the staging project. And we also have another cloud project with the exact same spec, right? But if you remember, this is on a new feature branch, which can technically deviate from the staging branch. You can keep rapidly developing on this particular branch, the new feature branch, and push changes to this project. And once you're happy and satisfied with the feature and have done testing, you can then move to this project, which is on the stage, which is connected to the staging branch. So once you push to the staging branch on GitHub via repository, you will get the changes getting reflected over here on this project. So for the same app, for each branch, for a feature branch, for a staging production branch or master, you will configure individual Hasura Cloud projects. and the directory will be the same. And you will keep deploying changes for the features, then go to staging, and then to prod. Right. So the automatic mode will ensure that this is happening smoothly. But in cases where you want to aggregate a lot of commits into a single commit deploy to reduce noise, you can do a manual deployment as well, where the mode is selected to be manual, and you click the deploy now button for any of the commits that you prefer to actually deploy manually. So that's under your control. But typically, we want to put this in autopilot where things work automatically in the background. You keep pushing commits. You don't worry about what's happening in the background. Right. So the next step would be, what if something goes wrong? How do I debug this now? Because things will look smooth when you're actually doing this git push when things are working. But what if I actually end up making a change? So I'll just gonna do git checkout, new feature. So come back to this new feature branch. I actually, let's we make a change. Say we make a new change. So we go to 9695 and let's create a new column. Let's create an updated that column. Not nullable. Let's make. So we've created a new column. This would have definitely created a migration file. Yes. I'm going to do a change here. So this will be 801 up.sql. Okay. So let's say we actually change this to article 1, which doesn't exist. And I add a comment. Let's say typo. This is not a real life use case, but there are cases where you're merging commits between different people and there's some merge conflicts, and then eventually ended up being a wrong commit being chosen to deploy. So we've pushed it to new feature, which means it would be on the second project, which will be the optimal project. So let's go to the Git deployment, and we can already see that it's already failed because the apply failed due to the Postgres query execution failed error. It says basically public article 1 does not exist, right? So this is something that it's clearly visible on the error message. So now post review or post some step, I end up now changing that back to whatever was the working table name. I see the Git status. I had it. Table name. So this is the commit that I do for new feature. And I do a git push again. So you don't need to worry about doing a revert on the commit and whatnot. So you can technically just keep pushing new commits, and then Hasura will take care of applying the change. So we have fixed the table name. Now this is getting applied. Metadata will be applied, and you have migrations. This time around, the apply worked. So we have a couple of skipped, and there's one applied. So wait for the health check to wrap up. And it's done. So let's go to launch console. And the data tab. So let's see the article table. We have the updated timestamp coming up over here. So we've pushed this to a new feature branch by git push. And again, I can go to staging, merge new feature, So I'm going to do a git push staging, and before do that, I'll open up that project, show the logs quickly one last time. So there's only one commit that's been done before, so I'm going to do another push to origin. And now we can see a couple of commits being applied. This one is skipped because this is an error anyway, and this is the second old commit, and this is the latest commit that's coming up over here. We can look at logs. This is already successful. We've seen the metadata and migrations passing through. So once the health check is done, we are done. So yeah, this is done now on staging. So I can launch console for the staging project. And your new feature branch and the staging branch is in sync. So those respective projects are now in sync, right? We can verify that by going to modify, and we can see the updated red column being added. Awesome. So what we've done is we've covered two use cases. One initially where we started from Hasura Cloud and then moved to local dev. We did a bunch of steps on the CLI to skip execution and then apply the migration and exported metadata as well. In the second use case, we already had that same CLI project, but then we wanted to move that to a staging environment on Hasura Cloud. We just literally created a new project and then used the same database env for connection, and then did a simple git push. We connected it to a staging branch on GitHub, and then we did another git push, and then everything started working. So typically without this feature, what we would have essentially done is we would have done a Hasura metadata apply, then you would have done Hasura migrate apply, and finally you would have done metadata reload. And of course, I'm ignoring the flags like the endpoint admin secret and any other flags, the database name flags, right? But if essentially, these are the three different commands that you would have run every time you made a change, and then that you wanted to apply it to a different project, right? So and the project URL will also keep changing between feature branches and your staging and dev branches and broad branches, right? So that's an overhead that you were probably be maintaining so far. If you're on a CD setup, then obviously that's going to be taken care. But this makes life simpler, where you just configure a branch, repo, and then just keep pushing changes automatically. Right. So Victor has a couple of queries, I think. Make the super app from GitHub to brand new Hasura interface. Awesome. Let me know how that went. The super app is actually a pretty complex app, to be honest, and it basically covers all sorts of use cases with Hasura, including custom business logic, your auth, JWT, and events as well, right? So everything around that would be pretty complex to talk about. So let me know how that went. The next question again from Victor would be, how about seed from GitHub? Right, so everything will be the same. So if you actually had seeds directory filled with some initial data, that will be also applied for your initial step when you do a git push, right? And the next question is, can I just do Hasura console and keep the changes in sync? So when you're doing Hasura console from the CLI, you're opening this, which one? Yeah, this localhost 9695 project. What is essentially happening is the changes that you make on this console, there are files being created, the migration files and metadata files being created on your directory by the CLI. So the CLI talks to the server, and then once the successful operation happens, the files are getting generated. Now, if you want to automate this to apply to a cloud project, You can technically listen to the file changes and then automatically apply, but I wouldn't recommend that. So the recommendation is obviously once you're done developing a feature, you commit to Git and then you do an apply migration step. So if you want to do it manually, that would actually involve the step that I mentioned, Hasura migrate apply, metadata apply, and then reload every time you want to do that change to any project from your local dev. But yeah, this GitHub integration should make life easy for you, where you just don't worry about doing those commands every time you want to make a change. Awesome. So yeah, thanks, Victor. Thanks for those questions. Do give it a shot. Do try out on your repo. We actually are improving the UX around this to make error handling a little better. So if you're stuck on something, you can actually fix. The troubleshooting guide is getting better right now. Right now you can look at this GitHub repo. So I'll actually put the banner over there. This is the GitHub repo that you folks can look at. And also drop a link on chat. And what about that? And add Brian's question. Is there a reason to track all functionality not done automatically rather than manually? So I assume the track all function that you mean is the track relationship and track tables. So the use case here is we don't want to assume that you want APIs for all the tables and you want all kind of relationships to be part of your GraphQL schema and API. In a very complex app, let's say there are some tables which are sensitive and you don't want to expose it on the API layer, right? Or there are some schemas in your database which you don't want to expose to GraphQL. It's just probably just Postgres or probably just the database specific stuff, and you don't want to expose them as the API layer. So if you technically just uh, want to just expose whatever you want for your end application on the front end to be used. That's the primary reason why we want to let you track whatever tables that you want. And obviously, going one by one on each table would be a very painful process, and that's why this track call is a nice feature to quickly get started. Using the CLI, uh, you can programmatically modify the metadata files because you have control over how you generate the YAML files on your directory. So you can generate YAML files or whatever tables that you want to track under whatever database and schema. Right, so I'm going to hide this one. Victor has another question. Where do we post questions? It's probably there are a bunch of places. We have the Discord channel where you can join and the community will be able to answer. We also have GitHub discussions where you can post post any issue that you're facing. GitHub issues are also there if there's a bug that you want our team to look at. But I think Discord will give you quick access to the community members where you can discuss potential integrations, potential solutions for issues, and GitHub discussions for further tracking and any feature enhancements that you want. Cool. Yeah. So Brian's follow-up is basically it would be nice to have a flag to set it, right? That makes sense. So you can automate it as well. I think there are some external tools in the open source community who've done this where the track all is part of your init step when you start the server and you connect to a DB and then the track all API happens. Technically, it's just a metadata API call. So you can use tooling, external tooling or programmatic scripts to automate this step as well, if need be. But I think there's probably already an open issue where you want to track this automatically for some use cases on a flag type. So, but yeah, I think the recommendation generally is to selectively choose which tables you want to expose and not assume that everything needs to be exposed on GraphQL schema. Cool. I think we are just on time, so we can probably wrap this up. I think some good questions from Victor and Brian. So thank you, folks, for signing in. Do check this out. Right. Next week, I think we'll have a new episode where Jesse will be joining in, talking about some low code, no code stuff with some integrations. That'll be pretty exciting. So we already have a couple of blog posts which we published recently around no code, low code. One with draft bit, and then one with bubble recently. So that's going to be exciting as well for next week. And we have a lot of new episodes lined up for the next few weeks, and it'll be interesting to uh, keep notifications on for that because we have some exciting guests joining in for September as well. Right? Awesome. Um, thanks, folks. Thanks for joining in. See you around. Until then, bye bye. See you.